when we can do something one way, we can always do it the opposite way as well. So we can do something called an inverse. Okay, so in a function, we can, if we go from angle to ratio like we did above here, so we had a tan function that converted the angle to ratio, we can do the opposite and go from ratio to angle. And the function that we use is called the arctan, or the inverse tan function. So if tan goes from angle to ratio, the inverse does the opposite, or goes from ratio to angle. And that function can be found on your calculator as well. And that one is the tan with the little -1. That little -1 in math indicates inverse when we talk about functions. Okay, it's not an in this case, it's not an exponent. So here we have angle A. Okay, we could have put angle A down here because this is isosceles triangle. And the tan ratio is 1 to 1. So if we wrote it out like this, if I knew what angle A was, the output is going to be 1 to 1. But I have the output, I want the input, which means I need to do the opposite or go backwards. So I need to use the inverse function, and the tan -1 is what does the inverse. Okay, so if I want to know what the angle is, I put it into my calculator like this. So these are equivalent, but one is calculating the ratio, which I already know. Here, this one outputs the angle, which I don't know. Okay, so although these are equivalent expressions, to find the unknown piece here, I need to use the arctan, or the inverse tan. So if you take a look at that picture, this is one where we really don't need the calculator because we know what that angle is. We're familiar with this shape. We know if it has a shape of with a ratio of 1 to 1, that angle is 45 degrees. But we're going to check this. So on my calculator, I go arctan, or inverse tan of 1. And the output is, this is what I expected. It is 45 degrees. My calculator is giving me the right angle. Okay, so this is what we're going to do then. We're going to find the angle when we know the shape of the triangle given the sides. So here we're going to use a tan ratio. To use a tan ratio, well, I need to use Pythagoras, so I'm going to need to solve for that third side first. So I'll call that x. And it is a shorter side, so I need to subtract. So I'm going to go the long side. The hypotenuse is always the long side, minus the shorter side. Okay, so I get 169 minus 144. This happens to be a Pythagorean triple. So we get a perfect square of 25. So x is equal to, when I square root this, I get plus minus 5. And again, we're just going to use the 5 here. Okay, so there's my opposite side length. Okay, this is going to be x equals 5 as that length. Okay, so if I were to use tan, it would look like this. I'm going to go tan of angle A equals opposite over adjacent. Now the problem is I already know the output of tan. What I want to know is the input, so I need to go backwards. So I need to rewrite this. I need to use the opposite. So the opposite, when I know the input is the ratio, the output is going to be the angle. Okay, so when I now put this into my calculator, and it's important to be able to write it in notation like this, okay, because we're going to have to be very familiar with this notation later on. So this is why it's important to actually write down the tan of angle and be clear. This is the tan of the angle equals the ratio. The inverse tan of the ratio equals the angle. Okay, so be keeping that straight. It's going to be very important. So we're going to do inverse tan of 12 divided by 5, and that gives me an angle of about 67.38 something. I'm just going to round that to 38 degrees. And notice I'm using 2 decimals here, and that differentiates my answers from my calculator of angles versus answers that I use for ratios. So if I just go back up here, notice that the ratio that I got from my calculator, I'm using 3 decimals. Okay, that's not really a rule, but that's just makes it easier later on if we get into that habit. Okay, so how are we going to use these concepts then to figure out triangles, solve triangles, which means, so solving means we need to find all the unknown sides and angles. Okay, so this one here, we've been given an angle and one side. So this one, the angle part is probably going to be easier to figure out because we can just know that these two angles add up to 90 degrees. So I'll just solve that angle first. And so I'll call that angle A maybe. I know that 35 degrees plus angle A always adds up to 90 degrees. So A is complementary to angle 35. So it's going to be 90 minus 35. Okay, so our angle A in this case ends up being 55 degrees. Okay, great. So I want to now solve for the side lengths. Well, I can't use Pythagoras because I only have one side. Okay, so I need to be able to change this angle description of this shape to a ratio description of this shape so I can work out side lengths. So I only have tan right now, so I'm going to use my tan ratio. Okay, so I'm going to have to come up with the ratio. Well, I just don't come up with it. I have to use my calculator to get it. And I'm going to use a tan function. So if I input 35 degrees, I'm going to end up with a ratio of 0.700. Okay, and that's a ratio compared to 1. My calculator only gives me the decimal, 1 decimal, but I know the other number is 1. And so what I know about this triangle is, I know that although this rise and run, this rise of x and run of 12s, is opposite over adjacent, is not going to be, 1 to 0.7. Okay? We know that that ratio is the similar ratio to what these two sides are going to give us. So I'm going to set this up. So I know that the opposite of angle A to the adjacent angle A is going to be x to 12. And I know that this ratio, I can solve that algebraically. Okay, so if I cross multiply this, I'm going to get 0.700 times 12 divided by 1 is going to be equal to x. So then I do that calculation, and I get the length of x is 8.402, so I'm just going to round that to 40. So this length here is 8.40. Okay, so what this tan ratio is saying is that this is about the opposite side is about 70% the length of this side, which is true. That is about 70% the length of 12. So there it is. I've now been able to go from the angle to the ratio. I had to use my calculator here, but once I get the ratio, again, I'm just dealing with a proportional equation because I have ratio to ratio comparison. So for the third side here, which I'll call C, I could use trig, but I'm going to just use, because I don't know which ratio that involves the hypotenuse, I'm just going to use Pythagoras for now. So C squared is equal to 8.4 squared plus 12 squared. Okay, so calculating C. So squared, 8.4 squared plus 12 squared is 214.6. And solving for C, I get plus minus the square root of that. Okay, so I'm just going to square root that on my calculator here, and I get 14.65.